All right, here's a video I put together to show the things we did at the end of class the other day for section 2-1, problems 87, 89, and 91 in your textbook. And I'm going to do it a little bit more simply with the calculator than the way I showed in class. So it's kind of the minimalist use of the calculator, if you would, for solving this problem. So what we want to do for these problems, first off, it gives us a table with demand, X values of demand in millions of units, and price. And it says do a linear regression to create a price demand linear function. So it wants us to use linear regression to create, the X equation over here for price. And to do linear regression, you need to put the X values in one list and the P values in another list in your calculator. And the way you do that is you go to the Stat button, you click Edit, and puts you into the list editor. And you just type 1, 4, 9, 14, and 20 into one list, and 72, 63, 48, so on and so forth in the other list. One thing I will mention, if you use your calculator much, you're going to end up with data in these lists. If you want to clear out a list, the easiest way usually is to up arrow into the list name, hit clear, and then enter, and that'll wipe out anything that's in your list. The only thing I would caution you on is when you do that, when you up arrow and you're in the list name field, don't hit the delete button. If you hit the delete button at this point, you're going to make list L1 go away, and you can get it back, but it involves a couple of other steps. You're better off not doing that. So if you go up into the list 1 field like that, just hit clear and it'll clear the list out. So I need to type 1, 4, 9, so on in there. 1, 4, 9, 14, and 20 go in the list 1. I need to right arrow over to list 2 and type in these numbers. Now I'm going to start using my computer keyboard instead of pressing the buttons on this calculator program to get these numbers in. 48, 33, and 15. Okay, I'm going to double check to make sure I got them right, which I did, which is something I always recommend on a homework or a test. So now I want to do a linear regression using these values for X and these values for Y. To do a linear regression on your calculator, you click Stat. Linear regression is on the Calc menu, so you right arrow once, and you want option 4, so you down arrow to option 4 and hit enter. And it puts linreg AX plus B, which is the linear regression function on your calculator. Now at this point with your calculator, if you just hit enter, it would do the linear regression, because linreg AX plus B assumes that if you don't tell it any differently, that your X values are in list 1 and your Y values are in list 2, which is in fact what we have. But if your X and your Y values were in other lists, you would have to tell it. So I'm just going to, for me, just using a calculator, I always put the lists in, even if it's list 1 and list 2. So to tell it to use list 1 for the X values, I'm going to use this L1 that's the second function above the number 1. So I'll click second, number 1, and it puts L1 in there. Comma, I'm going to tell it to use list 2 for the Y values, and again, I'm going to use this L2 above the number 2. So I'll do second, number 2 for L2. Now I can hit enter, and it'll do the linear regression using these values which I typed in list 1 and these values for Y that I typed in list 2. And it tells me the price demand function is AX plus B. In other words, the price is minus 3, which is what A is, times the demand plus 75. So my P of X is minus 3x plus 75, or if you want to write it as 75 minus 3x, it doesn't matter. Okay? So how would I predict the price for a demand of 7 million units? I would just plug 7 into here. I get minus 3 times 7 plus 75. Okay? My demand is 7 million. That's my X. I use minus 3 for A and 75 for B. Hit enter, and it says the price of $54 would result in a demand of 7 million units. So that's how you'd use a linear regression and a price demand line to predict price. So the second part of the problem says create a revenue equation from that price demand equation. Well, what is revenue? Let's get out of algebra for a second and talk about business. What's the definition of revenue for a business standpoint? Revenue is how much money you put in your pocket based on selling things. And it's the price you get per unit times the number of units you sell. If you sell 100 iPhones for $50 a piece, you get $5,000 to put in your pocket. Okay? Revenue equals price times sales. Now you might say, well, wait a minute. That doesn't say sales there. It says demand. The demand equation says how many units are people going to want for a particular price, or to get a particular demand, what's the price going to have to be? Universally in business, demand is equated to sales, at least when you're doing a prediction. Okay, it's the only thing you can use. Do you ever actually sell exactly the number of units that your price demand equation says? Probably not. Things change as we move along. Okay, but it's the best thing you've got to do a prediction. So revenue is price times demand. Now let's go back to algebra. I've got an expression for price. 75 minus 3x, where x is my demand in millions of units. I've got an expression for demand, which is x. So my revenue is just x times P of x. I just put a x times 75 minus 3x, which is my price equation, and that becomes my revenue equation. If I want to fill in a table, I just have to take my x values, like 4 million units here, and plug it in. 4 times 75 minus 3 times 4 will tell me what the revenue is for that. Let's do that on a calculator. 4 times 75 minus 3 times 4 is, for a demand of 4 million units, my revenue would be $252 million. Let's see what I get for a demand of 8 million units. I'm going to use the entry second function above my enter button to recall this entry and edit it. So I'm going to do second entry and go back, and where I've got 4, change it to 8. So 8 there and 8 there is going to give me a prediction for revenue for 8 million units. And it's $408 million revenue. That's how much money is going to come in if I sell 8 million units at whatever the price is going to end up being based on my price demand equation. I'm not going to fill in that table. You can go through and plug in 12, 16, and 20 for X and E's and fill the table out. And I'm not going to sketch the plot the data points. But we do want to look at the graph of this revenue function. So how do you use the calculator to look at a graph of a function? You got to put the function into one of your y equal to functions. So you press y equal to, which is what I just did, and there's a whole list of different, you can have 7, you can actually have even more. If you scroll down, different functions, different graphs on your function. A calculator is a graphing calculator, and it likes to put graphs up. So I need to put this function, this revenue function, x times 75 minus 3x. To get an x, you use this xt theta n button here. So x, open parentheses, 75 minus 3. And again, I use this thing button here for my x again. And there's my revenue function. It's in y1. I want to see a plot of this, so I'm just going to hit the graph button. I was like, oh, wait a minute, I'm not seeing anything here. Why? Well, the calculator, you need to scale the x-axis and the y-axis appropriate to what your function is. How do you do that on the calculator? That's all controlled under the window button. So click on window, and right now this is left over from whatever I needed the last time I did a graph. It says the x-axis that I'm seeing there when I hit graph goes from a minimum of 9.65 to a maximum of 10.25. That's not what I want for this. My x value, my demand is, in the range of 1 to 20. And I really probably want to see a little bit further outside that range. So I want the left end of my x-axis to be a demand of 0. And that's what x min is. What do I want the right end of my x-axis to be? Well, I'm going to go a little bit above 20. I'm going to make it 25. Okay, so now when it draws the graph, the x-axis, the left end of the x-axis is going to be whatever x min is, 0, demand is 0. And the right end of the x-axis is going to be whatever x max is, which is right now 25, demand to 25. Now I'm going to go down to my y-axis. The y min and y max tell me what's the lowest and highest values for y that I want. Well, the lowest value for y I want to see is a revenue of 0, so I'll go ahead and put a 0 in there. There may be other problems where you don't want to see 0, or maybe you want to see a negative number. I don't know, but for this case, the lowest y value I want to see is 0. What's the highest y value? Well, when we played around with this, we got revenue of 250 million for demand of 4, and a revenue of 408 million, I think it was, for a demand of 8. So, these numbers are 250, 400. Let's put a y max of 500 in there. That way, if the revenue equation goes up to 500 somewhere along the line here, it'll still be visible on the graph. So I hit the window button, and just from analyzing the situation, decided what's the range of x values I want to see on my graph, what's the range of y values. If you don't get it right the first time, you click graph and the equation is chopped off at the top or something, you can go back and change the window. If I hadn't put a high enough value for y max in, it would have chopped the equation off at the top. So I'd have to go back and increase the y max. So this graph is now showing demand for demand values from 0 up to 25, and it's showing revenue values from 0 up to 500. And we can see that our maximum revenue is probably somewhere slightly below $500 million. So that's how you plot the graph of the revenue equation. So let's go look at the next step. It gives us a cost equation, and it says our cost is 125 plus 16x. What does that mean from a real standpoint? Well, it says that these are in millions of dollars. So it says to build a plant that's going to produce millions of whatever these widgets are, you got to spend $125 million to build the plant and whatever other fixed costs there are. And then on top of that, for every one you produce, it's going to cost you $16. And we want to create a profit function from that using our revenue function that we've already got. Well, in business, the definition of profit is revenue minus cost. Revenue is how much dollars do you get in for selling things. That's what this is, x times 75 minus 3x, minus the cost. This is what you got to pay to build the plant and buy the materials that, and pay the people and whatever else to create that number of widgets. So our profit equation is just our revenue minus our cost. This is our revenue that we got by taking price times demand minus the cost. Now, where's this cost equation going to come from? That's going to come probably from your production ops people who are, you said, hey, I want to make, 10 million widgets. What's it going to cost me to do that? And they go off into their corner and decide that, you got this $125 million plant that you need to build, and then after you do that, it's still going to cost you $16 per widget. So that's where your cost came from. Maybe it came from a linear regression from some other set of data. I don't know. This problem, it was just given to us. So that's our profit. Well, let's put this equation. Let's look at that equation on our calculator. And I do it by putting it into a y equals. I want to leave my revenue equation in there, so I want to use a different y equal for my cost equation. So I'll just down arrow 1 to y2, and I'll just type in x times 75 minus 3x minus 125 plus 16x. And there's my profit equation. Okay, so y1 is my revenue, y2 is my profit. And I'm just going to go ahead and y3 and put my cost in. 125 plus 16x. So that when I do my graph, I'll see all three of those. Now, how would I actually calculate and fill in this table for profit? Well, I just, to get what's the profit for a demand of 4 million units, I would just plug in 4 here and here and here, 3 different places in my profit equation, and it'll tell me what the profit is. Let's go do that. And again, when you're in a window like this and you want to get back to your home screen, you do quit. So I'm going to do second quit. And I take 4 times 75 minus 3 times 4 minus 125 plus 16 times 4, and that's plugging 4 in for X, a demand of 4 million units, into my profit equation. And it says my profit for a demand of 4 million units is $63 million. What's my profit for a demand of 8 million units? Well, I'm just going to recall that entry by using second entry again and go in wherever I got 4, I'm going to change it to 8. So it says for demand or sales of 8 million units, my profit would be $155 million. So better than the profit would have been for 4 million units. So I definitely would want to go. And to fill in this table, you would just go plug in 12 and 16 and 20 in for X in this equation. What's the plot of all that look like? Well, I don't need to play around with my window anymore because the settings I've got to show revenue should be fine to show cost and profit. And in fact, there's the profit and there's the cost. So what I'm looking at on my calculator screen, and all I did was just go back and click graph because I already got my profit and cost equations in y equal. The big graph is the revenue, which we had before. The straight line is the cost, and the lower one is the profit. Now you might be asking yourself, how do I know that this straight line is the one that's the cost? Well, look at the cost equation. It's mx plus b, 16x plus 125. That's the equation of a straight line. So the cost, whatever, this equation is, when you graph it, it's got to be a straight line. The revenue equation has got an x squared in it. The profit equation also has an x squared in it. It's the same x squared. So revenue and profit are both parabolas, and the higher one is revenue. Profit's always less than revenue unless you're stealing from somebody. So that's how you would go about creating revenue equation, creating a profit equation, graphing them on your calculator. And again, different situations you're going to have to use different values for x min, x max, y min, and y max in your window in order to get your graphs to show up. And if you do like I did earlier, where the first time I hit graph I saw nothing, generally that means your windows aren't set up appropriately for what you're trying to graph. Okay. So go in and think about what are the x values and the y values that make sense for the graph that you're trying to show. And it's going to be based on what values for x and what your revenue values or your price values or whatever it is that you're graphing should look like. Based on this, my profit could be negative, so I could go change my window for y to be minus 100 or something like that. I don't care about that. I don't care what my profit equation looks like for negative profit. I don't want to be operating in that region anyhow. What are a couple of the things that you might care about for revenue and profit? Well, let's see. Like, what's the most revenue I could get? The calculator can help you with that. Above the trace button, there's a function. The second function is called calc, and it allows you to do some calculations on things that are being graphed. So let's do second trace, and I get the calc menu. And one of the options on there is to find a maximum. So we'll scroll down to option 4 and hit enter. And the calculator is now going to walk me through and help me find the maximum for a curve. Now, I've got 3 curves up here, and the calculator wants to do it for one of those curves. And it started off by offering to do it on Y1, which is actually the one we want, which is our revenue equation. But if that's not the one I wanted, you can use your up and down arrows to move the cursor from one equation to another. So if I up arrow, notice it moves the cursor to the cost equation, which is Y3. If I up arrow again, it moves the cursor to the profit equation, which is Y2. Those aren't what I want, so I want to do Y1, which is my revenue equation. And now, the way the calculator works is it's going to ask you for a left bound and a right bound for the area of the curve that you want to find the maximum for. These curves, profit and cost don't, but you can have curves that go up and down and up and down and up and down, and it can have multiple maximums. And so it wants you to define the region in which to do the maximum. So it's asking you for left bound ? And you just use your left and right arrows to move the cursor to left of whatever maximum you're trying to find. And that's what I did, and you hit enter. And then it says right bound ? So it wants you to move the cursor to the right of the point on the graph that's got the maximum. So I do that, and you hit enter. And notice it put a little couple triangles on there. It's going to give you the maximum between those 2 points. But it still wants one more thing. It says guess ? So I want you to move the cursor back to about where you think the maximum is. It doesn't have to be too close, really. And hit enter. And it goes and chugs off, and it says the maximum profit comes for a demand of 12.5 million units. Revenue. Maximum revenue is going to come from a demand of 12.5 million units. And the revenue is going to be $468.75 million. $468,750,000. That's dollars you're going to have in your pocket for producing 12.5 million units using the price demand equation that we've developed before. Okay. What else might be nice to know? Well, what's the maximum profit? Revenue is fine, but unless you just like touching dollars, what you really care about is profit. So let's find the maximum for profit. We're going to use the calc again. So second, trace, go down to option 4, hit enter. Except this time I don't want to be on the Y1, which is my revenue. I want to be on my Y2, which is profit. And so I just hit up arrow a couple times until it got onto the right graph. It still wants to go through this left bound, right bound guess process. So I move my cursor over left on the profit equation until it's left of the peak, and I hit enter. And I move it over to the right of the peak and hit enter. And again, it puts our little triangles up here. So it's going to give me the maximum of that graph between those 2 points. And it still wants our guess. So I'll move back somewhere in the middle and hit enter. And it tells me the maximum profit is going to come from a demand of 9.8333 million units. And our profit is going to be $165.1 million. And that's the maximum profit. That's the maximum for the amount that's left in your pocket after you collect all the money and then pay out your costs. Okay? What's the price for that? Well, I need to plug, let's go back to our price equation. Price is 75 minus 3x. So I got to plug 9.8333 into that equation to figure out what the price is. So let's quit this. Clear that just to make it a little bit easier. 75 minus 3 times 9.8333 tells me the price per unit for maximum profit is $45.50 per unit, and will give me for selling 9.833 million units, will give me a profit of 160-something.1 dollars. 162.1, I think, was the number. 165.1 was the number. And this is kind of, this is the graph that we just got finished seeing. The X scale is a little bit different. In class, I actually plotted stat plots with the numbers in them. You don't need to do that. I didn't bother doing that this time. So that's how you'd go about using a calculator, at least minimally, to get the information that you need for those 3 problems.